So let's get started with track 2. We would like to welcome Arun Kumar Dhakshinamoorthy as our esteemed speaker. He is Performance Test Analyst from Cognizant Technology Solutions, who has nearly 10 years of experience in development and quality assurance. Arun would be speaking on Adaptive Learner. To know more about Arun, you can watch his video at this link, which I'll be sharing shortly. Over to you, Arun.
Thank you, Harpreet. So I'll just be sharing my slide.
Sure.
Are you able to see my screen?
Yes, I can see your screen. You can put it in a slideshow. Thank you.
So is that presenter view is available?
Yes.
Seen or okay?
Yes.
Could you
Great.
please minimize
Thank you.
that black box on the right side
Of MS
bottom
Team.
in MS Teams, or
that will hide
So
the
this,
part of that slide.
okay. Is it okay now?
Well, I can still see the box.
the MS Teams notification box.
Yeah, I just minimized it.
Maybe there is a delay. Yeah, you can get continued then.
You can get started.
Okay, great. Thank you very much. Hi everyone. Good afternoon, good evening, good morning, based on your locations. Hope you are well and good from this pandemic situations. I'm Arun Kumar Dhakshinamoorthy. I'm working in Cognizant Technology Solutions for nearly a decade now. I'm working as a performance test analyst in NFT COE. I spend my time on end-to-end performance testing life cycle, from gathering requirements, doing test analysis, understanding the applications, and designing strategy to test performance test, and provide performance reviews and help client to get the application good performance. So I want work closely with client in doing all these activities. I work on mostly Java-based applications and performance tuning activities. I work on the CI/CD pipelines. Interested in doing DevOps and automation, end-to-end performance testing lifecycle. Currently, I'm involved in learning machine learning to do analysis on like how the data we can categorize, we can analyze the patterns in the huge volume of data that has been generated, and how to use machine learning based algorithms in our day-to-day testing lifecycle. So moving on to the next slide. The agenda of this session is like I'm going to speak about what is adaptive learner, and how the adaptive learner plays an important role in performance testing lifecycle, and where it actually comes into picture. So I'm going to speak about those details and how it actually works, the steps involved in creating this adaptive learner. And normally when we speak about performance testing, we speak about performance issues, which we categorize as anomaly, and how these anomalies are being detected, and how to what are the classifications or performance issues we are going to see in anomaly detection. And based on all these data captured, how are we going to use a machine learning based model to train and to test the network. So I'm going to speak about deep learning based model, which is a backpropagation algorithm, which is going implemented using Python, and the key benefits and conclusions of it. So before moving on to what is adaptive learner, I just wanted to tell about what are the challenges and issues we face during the performance testing lifecycle. So starting from the data gathering. So in performance testing, we do a lot of data preparation activities. So a lot of data are involved since we have to do a performance testing with the production volume of data. So we have to segregate those data into batches and then do the testing. So a lot of manual work are being involved, and you do a repetitive testing, performance testing, to get a better performance, and to analyze all these details like JVM metrics, garbage collection, heap analysis. You spend most manual time on doing this, and doing a repetitive test also consumes cost. So you cannot do many rounds of testing in an FT environment or in production environment if you are tuning something, because like if you run more iterations, it will cost to the client. So to minimize all these problems, we have the the solution adaptive learner was created. Uh, Moving on to the what is adaptive learner. So I've segregated into four different categories like phases. Adaptive learner is an automated solution which provides a constant feedback for performance testing. So feedback is very important for every task. So based on the feedback, you can optimize your output. So based on feedback, you can go to the path where it's really good to do a performance testing. So automatically redefining the testing strategy. The next phase is to define the goal, what we are trying to achieve. So we have combinations of data, so we have to determine which data is really good, useful to do a load testing or to do endurance testing to see how the performance is at the JVM side or at the server side or the client side, how it is behaving with the different types of data. Next is to identify the
Arun, Arun,
bottlenecks.
Arun, sorry to interrupt you. Are you changing your slides? It
No,
seems
I'm just
that your screen is frozen, and we are able to see only the first slide where your picture is there along with your name.
so are you able to three boxes still identify bottlenecks?
No, no. Maybe you can reshare. Try to reshare your screen because there seems to be some problem in screen sharing. Yeah. Now we can see. Now we can see the three. Yeah. Do a full screen. Yeah. Now we can see the three
Okay.
boxes. Please go ahead. Yeah.
Okay. So sorry for that. There should be some problem. Uh, the final step is the machine learning based part. So during performance testing, we gather a lot of informations, so a lot of test results, data we collected. So we have to understand how can we effectively use those data. So if there is any issue based on our past experience, we have to analyze the data. For example, if there is any issue in the memory, how to tune the JVM parameters to get optimized performance. So machine learning based algorithm has been used to do this activity in tuning the parameter. Moving on to next slide. So to start with, where the performance adaptive learner comes into the picture of performance testing. During the design work, we capture the NFRs. So what are the NFRs? Response time, throughput, CPU utilization. We get all these metrics from the client. So from business analyst, we get all these details, and we create a workload mix out of it. So based on this workload mix, we define the scenario, script creations. So these are the manual tasks we do to get the details so that we could run a load test or endurance test. So these are the manual activities we do during the build phase. And during the testing phase, we run the test using different automation tools, industry standard tools like load runner, new load, or JMeter. And then once we get the results, we analyze those results. These are the task manual work is involved. And uh, to reduce this, we use a Python framework integrated with Jenkins to automate all these things. So there are rules and steps defined in the Python based framework, so that will initiate the test via performance center. So I have used a load runner with performance center. So we have REST APIs which could do this work for us. The scripts can be created, the scenarios can be uploaded. All these tasks can be done with the help of REST APIs. So once all these tasks are done, you'll get the results out of it. So based on the results, you need to provide analysis and provide the report. If everything goes fine, your performance test results good, looks good, your JVM utilization, CPU usage, everything is good, you can provide a good feedback. But if there is any issues, you need to analyze more and to see where the issues actually. So the adaptive learner comes into picture over here. All these test results that has been captured or sent into a database. So the CPU metrics during the time duration, all these things being captured from App dynamics, you can capture the CPU timings, what is the memory utilization of a JVM, and all these things can be collected from the metric browser, then uploaded into a database. The Python program, the adaptive learner program, actually gets those detail from the database, and based on the information, we are trying to analyze a pattern. So, what are the JVM parameters I'm currently using for my JVM, and what is the load, what is the subset of data load that I'm applying to the system, and how it's behaving with respect to that load to the system. And if I tune the JVM parameters, what is going to give? So finally, like we get the, like, the garbage collection timing is directly based on the load and the parameter. So you don't want to get a very high garbage collection timing, often garbage collection happening, and you don't want to get more passes during, and though that reduces the latency and throughput of the application. To identify an optimal setting, you need to understand how the application behave with respect to load and your testing data which you are passing through the system. So to do this, the algorithm will be analyzing it. We have used a deep learning ML algorithm. So that will give us a weightage to the parameters. So which parameter needs to be tuned such that your GC settings will be optimal. And based on that feedback, we rerun the load with that subset of data and analyze the test results. So this is a continuous process. How it actually works, what are the steps involved in doing this? So first step is that identifying the data scenarios. So as I spoke before, like we full volume data is required for performance testing. You cannot do testing with a limited volume of data, so you have to identify volume of data and what data sets you are going to use, and you have to segregate those data sets. Next, based on the based on the data and the workload mix you have captured, you're going to simulate the load with that workload, simulate the load with the workload mix. And by using the industry standard load tools like load runner, neoload, and JMeter, we can do that. Next is to analyze the problems. Adaptive learner program analyze the data sets, and it captures the CPU heap memory usage patterns for the application using the APM tools. Any problems in the memory usage, or any problem in the CPU, or response time issues, any throughput, that problems all are being captured and analyzed. High utilizations in the methods for the particular data set. So the data can also be like activates the methods which are not often used, but the usage of the method can give us a problem. So those kind of utilization metrics are also collected. Finally, about anomaly that are identified and the JVM parameters which needs to be optimized based on the application you are using. So it depends upon the basic settings of JVM parameters will not work for all the applications. So we need to fine tune it to get better optimized server settings, so that your application behaves well with the JVM settings. So to tune that, we are going to use the algorithm, deep learning based algorithm. So when I speak about anomaly detection, what I'm referring to anomaly is, so when starting phase, the requirement phase, we talked about how we will get the response time metrics, we'll get the memory usage from the clients. So those are the requirements we gather from the clients. So if there is any issues, SLA breaches due to the data and the test we have done, so those are collected as anomalies. So the transaction response time going beyond the business provided SLA. For example, we run different types of microservices. So if a microservice is behaving, it has to be below 1 second of SLA, but it's breaching and it's going beyond 3 seconds. That's a problem. So we have to capture those things. And high CPU utilization. So for example, the CPU max CPU can reach to its 80%. It should not go beyond that. The memory also have a threshold value of 75%. So it should not go beyond those threshold values, and how much frequently the garbage collection is happening. It should not happen often, and that will interrupt the system. So these are the information that we call as anomalies, and these are the details that needs to be collected to analyze and understand the pattern, how the data, the test you are doing, and how the server responds to it. So we collect the GC time frequency using the commands JSTAT and heap dump using JMap, and these details are fed back into the database. And we come to know, like, for this much of load, we have a utilization. This much of utilization, and how much the garbage collection happens, timing happens. So all these collected details will be analyzed by the machine learning based framework. So as I say about the machine learning based framework, most suitable approach we have considered for this between the JVM metrics and garbage collection time, the relationship between these things, by using an artificial neural network. When I speak about artificial neural network, what is it? The artificial neural network is just trying to mimic how our brain functions. So it consists of a number of neurons, multiple neurons, millions of neurons included, and each one do its activity to determine the output. For example, if I take an archery competition, so the person is hitting the target first time, he will look onto the target and just hit it directly. The next time he noticed that he just need to correct himself to the right or to the left, so that he can hit the center of the target and achieve what he is looking for. Same like that, artificial neural network using a backpropagation algorithm to train itself by correcting its errors. The optimal value of the weightage of the neural network is the desired output what we are looking for. Based on the weightage, we know like which parameter has a greater effect on the response on the garbage collection time. So what are the steps involved in this backpropagation algorithm? So to do this backpropagation in algorithm, we use NumPy in the Python, which is a very great library for doing all these calculations. So basically, it's a mathematical structure with neurons, like in stages. So we have, what are the stages we have here is like input stage, hidden layer, output layer. So these are the this is the basic structure of a neural network. In input layer, we have what are the input parameters we are going to supply for the network, and we can have more than one hidden layer. Here we have chosen only one hidden layer and output layer. So what exactly what we are trying to achieve using this neural network, and assigning weights. These are the weights that it's between the input layer and the hidden layer, and between the hidden layer and the output layer. So we are going to calculate these weights. First we will assign the weights randomly to them along with the bias settings, and then calculate it through the forward propagate method. So in forward propagate method, we have neuron activation, neuron transfer. We use sigmoid activation function or ReLU function to do the neuron transfer. So it's from moving from one step, from first parameter, calculating the weight along with its bias value, moving to the hidden layer. And from that hidden layer, we are going to calculate all the values to the first output layer. So the output layer will be the predicted value, but we know that for the example, like the entire duration of the test needs to be under 2 seconds. So the garbage collection time should be under 2 seconds. But our value gives 5 seconds for the first time. We need to uh, uh, control it. We need to bring down that value to the delta. So we need to find a delta value which is like a difference between the predicted value and the actual value, and we fed back into the network. That's how back propagation works. So it calculates the error rate, and it moves backwards and correcting the weightage over there and updating the weights. The weights are updated based by training the network using gradient descent. So by slightly increasing or decreasing the weight, how it responds to the error rate. So this is how the network is trained and it predicts the value. So this will run in iteration loops such that the error rate comes down to the value where it actually is equal. It's almost equal to the output value what we are expecting. So we'll find out based on that, we'll get a weightage saying like this parameter can be tuned so that it will have a high impact on the response time, on the time of the garbage collection. So this is the neural network I was talking about, and what are the input parameters we consider for JVM settings that have a performance impact. So we have the input layer, which is from M1 to M8, the hidden layer from H1 to H6, and the output layer. You can see that W1 to WN is the weightage for each input layer. We have minimum heap size, maximum heap size, new ratio. All these parameters are being collected from the JVM settings, which we will be initializing during the startup, and the throughput for the each test we have done. So all these things are being taken from the data which we had already run previous tests. It might be the load test or it might be the soak test. So based on the throughput for different data conditions, we are providing those values. So first, normally we used to normalize the values, so to select a value between 0 and 1, so that it will be easy for the neural network to calculate all the percentages. So output time for this network would be the garbage collection time. The network is trained to get that, and we'll get the weightage. Based on the weightage, you'll know like which parameter needs to be tuned, so that overall GC time depends on that. So this is not limited. This backpropagation algorithm is not limited to one particular problem. It can be used in a number of various testing issues. So you can use this algorithm to understand the relations between the data and what patterns you can recognize using those data. Bayesian optimization technique is also used to tune these JVM parameters to with the hyper parameters which we consider as weightage and bias values will be tuned based on the Bayesian optimization technique, so that it will improve the performance of the neural network. What are the key benefits we are seeing by implementing this solution? So we get to know about what is the bottleneck for the specific data conditions. So we can predict it before we can see the issues in production for a specific data condition. So we can understand the bottleneck and we can rectify it before. And using the simulated load with a different subset of data, we exercise the system so that we can understand the patterns of how it is behaving differently. By using the feedback system, we can optimize the performance. We know which right way we are going, and by optimizing the system performance, we can get better results. Automated feedback system based on the MI based frameworks, it helps to reduce the manual work and the cost, instead of spending more time repetitive iterative test, and then changing the JVM parameters, again running the test in NFT environment manually. That's going to take a lot of time. So to reduce that time, we are going to use this MI based framework in predicting what is actually we need to change. So that helps us very much. To conclude this section, we have identified the bottleneck, identified the methods which are based on heavily using the different data sets, By doing this, we can reduce 50% of manual work involved in collection, understanding, segregating of data, understanding the difference, like understanding the patterns between the data and performance test results. The issue is also identified faster because of the automation, and different scenarios are created based on the rules, and it's automatically executed. By optimizing the performance of the JVM parameters shared by the APM tools also helps us to optimize the performance of an application before going into production. So by this particular neural network can be used for any type of performance related or any testing related process where we tend to do more manual work in understanding the data, and when we have huge amount of data, we have to understand what is going what are we going the right track of this thing. So as that's all from me. Thank you very much for your time and patience. Thank you, ATGTR, for giving me this opportunity.
Thanks, Arun. We can take questions now. Just a minute.
So Arun, I do have a quick question for you. As per your experience, to identify those bottlenecks, as we can see in your conclusion slide, no, as a QA or to make use of some automation along with the DevOps and CI/CD implementations, how identifying bottlenecks to the entire setup can be made very easy? Like, what is the proactive approach of doing all of that?
So it depends upon what type of application you are saying. It's really a digital kind of application, or it's a very old application, right? So uh, uh, you have to understand the application better to come to a conclusion to verify whether I need to make proper settings. So can you
Okay.
be
The
more?
question was like more of a generic thing, like common
Yeah.
practices which you can think of or you have tried so far as per your experience, not specific to any specific application as such.
So generally we do right manually when we try to say, like, when we run the test manually, identify, like, tune a parameter and then check how it is behaving with the type of load. So that's how we do it manually. But when it comes to automation, you have different sets of tools which can be used to do this now. So that's how I would say, like, it's a general approach. You can do use the automation tools now to do all these works.
Mm-hmm. Okay.
Okay. Thanks, Arun. We have poll options available for you, for audience to give a feedback. Thank you so much for delivering
Thank
a
you very
session.
much.